What up, everybody? Instructabeats back again here with another coordinate planes lesson. Today we're going to be talking about finding the area of a polygon on a coordinate plane. So we're going to be combining some area knowledge with some coordinate plane knowledge and seeing how we can use those together. A little peanut butter and jelly today, if you will. All right. So today I will be able to find the area enclosed by a polygon by using my coordinate plane knowledge. So we're going to kind of be combining the past couple lessons. You're going to have to know how to plot points on a coordinate plane. You have to know how to find the distance between points on a coordinate plane, either by using the coordinate plane or the ordered pairs mathematically. And then you have to know a little bit about area and covering the inside of a two-dimensional shape, right? So a polygon in the coordinate plane is made up of 3 points, 0, 2, 0, negative 6, and 7, negative 6. What polygon is created by those 3 ordered pairs? And then what is the area of the polygon? So last lesson we focused on perimeter, just using the distances around them. Today we're going to be using that same skill, but applying it to area. So first of all, let's graph these ordered pairs. I have 0, 2, so 0 and then 2 would be right here. I have 0, negative 6, 1, 2, 3, 4, 5, 6 down. And then I have 7, negative 6, so shuffle on the carpet over 7. 1, 2, 3, 4, 5, 6, 7. And then go down to negative 6. Now again, my son loves to connect the dots. I love doing connect the dots as a kid. So I like to connect the dots first so I can really see the shape. It doesn't have to be perfect, right? But I can see that my polygon I made is going to be a right triangle. So what polygon is created, right? A right triangle. And I want to figure, there we go, spell it correctly. Okay. And what is the area of this polygon, right? In other words, how much space is covered on the inside of this shape? So a lot of people would like to think that you can just count these squares on the inside, which is great, except what happens when you get here, right? Is that a half? Is it less than a half? Is it exactly a half? This one's more than a half. So it's nice when you count the whole numbers, right? The whole square units. But what happens when you get to the halves or the thirds and you don't really know? Well, all we're going to do today is just use our area formula. We know our area formula is area equals 1/2 base times height. And that comes from the area of a parallelogram, because a triangle is going to be half of a parallelogram. Check out our area of a triangle song for that. But we're going to use the distance between the points to figure out what our base and height is. So obviously area, we know that's 1/2. What is the base of our triangle? So what is the distance between these? Well, we can just count those, right? So that'd be 1, 2, 3, 4, 5, 6, 7 units. My height for this right triangle is going to be in between these two right here, right? 1, 2, 3, 4, 5, 6, 7, 8. And so I could find the diagonal, but you can't just count diagonally, right? Because it doesn't work the same as horizontal and vertical. To do the diagonals, you have to have a little bit of triangle knowledge with the Pythagorean theorem, and we're just not quite there yet. But we will have a video on that later. So I know my base is 7. I know my height is 8, right? So 8 times 7 is 56. Half of 56 should be 28. So I think that this is 28 square units that cover the inside of my right triangle. So again, if I was going to cover the inside of the shape, there should be 28 square units. Now, let's just count real quick one by one just to see if we were close, right? Now, we're not going to count these kind of partial ones over here, but I should have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. And then I have all these partial ones up over here, which would add up to 5 if I could count them, but I can't. So today, all you're doing is using the coordinate plane to come up with the distances on the sides of the polygon to help us find the area. All right, so here we have our we do problem. Taking it to the next level. This should be you should be doing this in your notes with me. If you don't have your notes, check out the link in the description to the video. But we are talking about finding the area of this polygon that's created by 5 vertices. So I have vertex A, L, and X, and then it gave me some directions. And again, I'm talking about north and west here. So I'm going to think about this coordinate plane, right? North, east, never eat soggy waffles, right? Kind of as my directional compass right there. And let's go ahead and build this polygon by adding our vertices. So vertex E will be 4 to the north, of vertex X. So here's X. I'm going to go north 4. 1, 2, 3, 4. There we go. Vertex S will be 6 to the west of vertex X, which means we're going to start at vertex X, go 6 to the left on my x-axis. So 1, 2, 3, 4, 5, and 6. And I am going to connect my shape. And you can see right here that I have just made a pentagon. Now this line's a little bit crooked, but it is a pentagon right here, right? So I want to find the area of this pentagon. Okay, in other words, how much space do I have inside of here? If I was covering this with an array, how many square units do I need to fill up the inside of this shape? So this is where we need to combine our area knowledge here. Okay, we're going to decompose this pentagon into a triangle, which I'll outline in red right here. There we go. And then a rectangle underneath. And we're going to be able to use our ordered pairs and our coordinate plane to find the distances that we need for the sides in order to come up with the area. So we really have two different problems going on here. We have our area of our triangle, okay, which is going to be 1/2 base times height. And then we're going to have our area of our rectangle, right, which will just be length times width right there. And again, you could do this with your ordered pairs, but it's a little bit easier just to graph it. You can check out our other lesson on how to use the mathematical aspect of just adding and subtracting your ordered pairs and your X and Y ordered pair to find out exactly what you need. But graphing it and just visually seeing it is a little bit easier in our opinion. So we want to find the area of this triangle first. So here's the base of my triangle that I just decomposed out of my pentagon. And I'm going to have 1, 2, 3, 4, 5, 6 as my base. All right, there we go. That's 1/2. And then my height, I'm just going to go from my vertex L and drop it straight down right here. And I can see the height of this triangle is 2. And so when I multiply that out, I find the area of my triangle to be 6 square units, right? Because 6 times 2 is 12, and then divided by 2 would be 6. So I have 6 square units inside of this triangle. And now I've made this easy because I decomposed the area or the pentagon into a triangle and a rectangle. Now I can just count the distance between my vertices to figure out my length and width of my rectangle and multiply them together, right? So my base right here, or my length, I guess, if you will, 1, 2, 3, 4, 5, 6. My height is 1, 2, 3, 4. And so obviously 6 times 4 is going to be 24 square units. So if this were a test, I guarantee you 24 would be on there, and I guarantee you 6 would be on there. But if you go back to what we were trying to do at the beginning, we wanted the area of the entire pentagon, right? So now let's take those two distinct areas that we found and compose them back together. And so 6 plus 24 would give us a total area of 30 square units for my pentagon, right? So again, just taking our coordinate plane knowledge, our area knowledge, and like peanut butter and jelly, putting two awesome things together to make an even awesomer thing, all right? Even though I don't think that's a word, that's all right. Let's take a look at our you try problem. All right, so here's our you try problem. So a little bit of a word problem, a little bit of a real life problem here. So the city council is planning on building a Dairy Queen. Love Dairy Queen. Who doesn't love a blizzard? When they flip it upside down, it doesn't fall out. It's just like magic. Butterfinger blizzards are obviously the best, but everybody's allowed to have their own wrong opinion. Represent the point on the coordinate plane on your notes. So you have this on your notes. Check out the link, and again, in the description video for your notes. We already have a library, a church, and a school already built in our town. The city council is planning on building a park in the area between these 4 landmarks. So here are 3 of our 4. You need to graph where the Dairy Queen will be. And then the question is, how large of an area will the park have? So you're going to graph the point, what polygon is there, and then use your area knowledge to find the area of that polygon. If you're not ready to try this by yourself, you can just keep watching as a we do problem, just add it into your notes, okay? And if you are ready to try it by yourself, you're going to go ahead and push pause and then push play when you're ready to check your work. So hopefully you just paused it. So the first thing we want to do is graph our Dairy Queen, right? That's going to be at 0, 1. which is going to be right here. So when I connect this, I see that I have made a parallelogram. All right. So the area formula for a parallelogram is just area equals length times width. Okay. And remember though, we're not counting diagonals. Okay. That's not going to be the length of your parallelogram. Okay, or the width of your parallelogram, depending on what you want to call it. So this one's a little bit easier because it's a horizontal. So we have 1, 2, 3, 4, 5, which means this is also going to be 5 units. But again, we don't know how to count diagonals yet. You actually would have to use the Pythagorean theorem to figure that out. So when you find the height of a parallelogram, just like you learn when you're learning your area lessons, take this vertex, right? And you're just dropping it straight down. How tall is this? And this is a straight vertical line. So I can use my coordinate plane to help me count. 1, 2, 3, 4 is going to be your height. So my area is going to be 4 times 5. So my area of the park, the size of the park, would be 20 square units. So we don't know if it's square feet, square yards, square miles, square, I don't know, acres, who knows. But on our coordinate plane, the area of the park they'd be able to build between the 4 landmarks would be 20 square units. So hopefully you got that one right. If not, it's okay to fail as long as you learn from it. You go back, rewatch the video, check out our other videos if you need to. We appreciate you checking us out today. We know there's lots of different options online, so we really appreciate you hanging out with Instructabeats. Please check out our website, Instructabeats.com. Check out all our merch. We'd love for you to subscribe, like the video, let us know where you're watching from. Again, thank you so much. Instructabeats out.